Good day, students. So, today we are going to go over exponent laws. Now, exponent laws are actually really easy if you understand them all. And this is what this video is about. I'm going to teach you every single exponent law that exists. There may be more, but this is your high school exponent laws that you need to know. And whether you're grade 8, grade 9, maybe grade 12 even, and you still can't remember your exponent laws, you can refer back to this video and we're going to go over the basics. Now, the first thing we need to know is that when we deal with exponents and with our multiplication, we are changing up our multiplication sign. You know when you normally had a cross, right? Let me show you over here. You see this cross over here? That cross is normally what we would use to multiply two different numbers or variables. But now we are going to use a dot to indicate that we are multiplying two different numbers or variables. So let's do this. First exponent law is x to the power of n multiplied by x to the power of m. So now, what is the exponent laws for? I'm going to tell you why. We need to find ways where we are actually able to add two exponents. The exponent laws are basically how can we add two exponents together, how can we minus two exponents, how can we multiply them, how can we divide them. And in this video, this basically shows how you do it. So whenever you have two of the same bases and x is the base of these two variables that are being multiplied with their exponents, as you can see, the x and the x are two bases that are the same. So, because the two x's are the same, or the two bases are the same, we can write this as one base. And now, because there's also a multiplication sign over here, what we can do is we can add the two exponents. This is an exponent law where you have to add the two exponents. Because this over here, we need to know, once again, how to add exponents. And obviously, we have two bases. When there's two different bases, that is a completely different case. Let's say this one was actually y, and this one is just left as x, obviously. Then that will be a different case. But for now, when you have the same bases, you need to just remember that you need to write it as one base on the other side of the equal sign, and then you need to just add the exponents together when you have a multiplication. So let's jump into an example, and let's just try and do a question so that you can maybe understand it a little bit better. Okay, so I give you three questions. The first question is using the first law of exponents. Now, the first law of exponents is the one that allows you to add the two exponents. Now let's analyze it first. We're going to learn how to analyze it first. The first step that we use is to look at the two bases. Are the two bases the same? And if you answered yes, you are absolutely correct. As you can see, the base that is shared amongst this expression here is 2. 2 is a common base that's used, so we can write it as one base now on the other side. And as you can see, we have a multiplication sign. And what we know about when two bases are multiplied, when they have exponents, we know that those exponents need to add together, which is going to be 3 plus 4. Now, if we just simplify that a little bit more, we know that 2 to the power of 3 plus 4 is equal to 2 to the power of 7. And if we were to write the numeric value of this one, we would know that that is equal to 128. Now, that is the first question. Now, let's look at the second question. The second question, we are working with variables. Now, let's look at the first thing we need to look at, once again, is the basis. We have x, and we also have x. Clearly, those two bases are the same. So therefore, we can actually write this on this side of here as x. Now, let's look at the exponents. Now, the second step is actually to look at the sign over here between the x, and you can see it's multiplication. So therefore, the exponents have to add each other. So let's look at the exponents now. We can clearly see that we have one exponent on the x over here. So this exponent right here. But we don't have an exponent over here. Where's our exponent here? by x. Can you guess what this exponent is going to be? Just pause the video and just think about it. If you said that the answer is 1, you are absolutely correct. Because, think about this, anything to the power of 1, let's say it's 2 to the power of 1, will just be equal to 2. Can you see that there's not an exponent on this side? Because clearly the 1 is just added. Let's say we say 5 to the power of 1. That is just going to be equal to 5. So as you can see, x to the power of 1 over here is just x. So what do we do now? We can now write as the exponents that we are going to add, we know it's going to be now 1 plus 2. So something to remember from this is whenever a number or variable or a base, does not have an exponent, you just write 1 by default. So now we have on this side, x to the power of 1 plus 2 is going to be equal to x to the power of 3, or x cubed. Now, we're moving on to the next question. 5 to the power of 2 multiplied by 5 is going to be equal to. Now let's analyze again. We look at the bases. That's the first step. The two bases, which are 5 and 5. You can clearly see that those are the same. So we just write it as one base on the other side because they share a base. Now let's look at the exponents. We have 5 to the power of 2 over here. So that is one exponent. And we have just multiplied by 5 on its own. But remember what I said? Anything that doesn't have an exponent, you put a 1 over there. So therefore, it now has two exponents. We have 5 to the power of 2, so we have 2 as an exponent. And because we have a multiplication sign here, we are going to add 1 over here because that's our other exponent over here. So it's 2 plus 1, which is equal to 5 to the power of 2 plus 1, which is equal to 3. 5 to the power of 3 is also equal to 125. So as you can see, this is how we deal with adding exponents when you have a multiplication between two bases, and the exponents will therefore add each other. Okay, moving on to number 2, exponent law number 2. Now remember, the first one, we added two exponents. Now remember, we also have to find a way to minus exponents, or we have to multiply exponents or divide exponents. So let's look at number 2. Number 2, you can clearly see it's a fraction, right? Which also means that it is dividing. So we can also write it like this, x to the power of n divided by x to the power of m. That is also another way we can write it, right? But now we are not really going to focus on that at the moment. We are going to focus on just the fraction on its own. Let's look at this fraction. Let's analyze this fraction, right? We have x on the numerator over here. So we have x as a numerator, as a base, obviously. Now, let's look at the base for the denominator. We also have x as a denominator, as a base in the denominator. So, what we can do is we can write this as just a singular base, but now let's just analyze our exponents. We have n. We have x to the power of n over x to the power of m. So what we must do, and what we should know about this law, is that we can minus these two now. So let's write this down over here. We have n minus m. Now one thing to remember, right? Whenever you're working with the fractions, right? With the order you need to minus them, it will always be top minus the bottom. Exponent. I'm going to write exponent as short, just exponent. So whenever you are working with fraction and we have exponents in a fraction, we will always minus the top and the bottom exponents. So that is the order. So this is basically the order at which we will minus them or subtract them. Now let's do some more examples so that we can understand this even more. Okay, now we are going into these examples. Now I have the first one over here. We have 3 to the power of 4 over 3 to the power of 2. Now remember, when we are trying to do the exponent laws or use exponent laws to solve these questions, we need to first look at the bases. Now let's look at the bases. The base on the numerator is 3, as we can see, and the base on the denominator is also the same. So therefore, we can actually just write it as one base on this side. Now let's look at the exponents. Or let's actually analyze what's happening, right? We can clearly see it's a fraction, right? Because we have this line over here. It just indicates that it's 3 to the power of 4 divided by 3 to the power of 2. And this indicates that we need to now subtract the exponents. Now, how do we subtract the exponents? Remember, it's going to be the top minus the bottom exponent. Now let's just keep that one over here to the side, right? We are left with top minus bottom exponent. That's the order we are going to minus them. So how are we going to write that? We have the top exponent over here as 4. So we write this first, the top first, and then we have the bottom exponent as 2. So we write that next. So we're going to minus now the bottom. And this is just going to give us, if we simplify further, 3 to the power of 4 minus 2, which is equal to 2. Which is also equal to 3 to the power of 2, which is 9. So that is going to be our answer for the first example. Now the second example, let's analyze again. We have the numerator base, which is x, and our denominator base, which is also x. So because those bases are the same, we can just write it as one base. Note that with these questions, we'll always write the final answer with just one base, where sometimes they share a base, you know. That is basically how we perceive it in exponent rules. Now, next thing we need to know, what is happening? This x to the power of 5 is being divided by x to the power of 4. So what do? Now we have to subtract the exponents. So what do? We take the top exponent, and then we have to, okay, so the top exponent, and then we just minus it by the bottom exponent. So it's going to be 5 minus 4, which is equal to x to the power of 1. And note, whenever we have x to the power of 1, we can actually just write this as x. Because x to 1, anything to the power of 1 is just, it stays the same. Now, in the third and final example for this one, we have 7 to the power of 6 all over 7 to the power of 8. Okay, we have a little bit of a weird one, but let's actually go through this step by step. We have the same base on the numerator, and we also have the same base in the denominator. So therefore, because there's the same base, we can actually just write this as one base on the other side, which is 7. Now, what is happening? They are being divided. Why? Because it has a fraction form. Now, what's going to happen next? We're going to take the top exponent and we are going to minus it by the bottom exponent. So the top exponent minus the bottom exponent. We are going to write this as 7 to the power of 6 minus 8 is going to be equal to 7 to the power of, what is 6 minus 8? That is just equal to negative 2. Now, we have a negative exponent, and you're probably wondering what on earth is going to happen with this one. This, students, is going to be this is what we are going to deal with soon enough. This is, I believe, the exponent law number 5, but let's not deal with that right now. Just know that this is our exponent law 2, where we minus the exponents, all these examples. Okay, now we are going to continue. Exponent law number 3. And also, if you made it this far into the video, I do think maybe there is some time for a break. You don't have to watch all of it at once. You can actually just spread it out throughout, like maybe hours or days, even if you have to. If it's a little bit too much, then just don't go too hard on yourself. Just take your time, learn it step by step, and because it's really important to learn your basics. If you mess up with your basics, you will not be able to answer complex questions. This is why I am making these videos, to just help you understand the fundamentals of each topic. So let's move on. Enough about my whole this whole thing over here, this whole scene. Now, remember, the first exponent law was to add the exponents. The second exponent law was to subtract the exponents. Now, what do you think this exponent law is going to be? Number three. This exponent law is where we multiply whenever you have a bracket. So you see this bracket over here and over here around the x to the power of n. We can see that this entire bracket is raised to the power of m. Now, what do we do in this case? We will write down, let's say, x to the power of n. Okay, so as you can see, our base, right, we only have one base, and our base is x. So we can just write x as it is because there's nothing else that's different about it. Remember, we can't just magically get rid of the x. Now, we have n over here so we have an n over here inside of this bracket, and we also have an m outside of this bracket. Whenever exponents are separated by a bracket, in this case over here, then we will multiply them. So how are we going to write that? We're going to say n times, remember I said we're going to write our multiplication as a dot, n multiplied by m. That is our third exponent law in this case over here. So once again, this is the exponent law where we multiply the exponents. And let's just go into some examples so that we can understand this a little bit better. Alrighty. So let's get to the first example here. We have 3 to the power of 2 all raised to the power of 2. Now, what is that? What are we going to do in this case? Remember, the first thing we always need to do whenever we are doing exponent laws, we have to look at the base. The base is 3. That's the only base we have. So let's just write it on this side here. Now, remember when I showed you the example or the main law, whenever we have a bracket, so you see this bracket over here and also this bracket over here, whenever we have something inside of this bracket, like so, that is all raised to the power of an exponent, we will multiply that outside exponent by every single exponent that is inside. So this 2 will be, or this exponent 2 over here will multiply by this exponent over here. Now let's do that. We have 3 to the power of 2 multiplied by 2. Okay, now how do we also write this? That's just going to be 3. We're going to simplify it even more. 3 to the power of what's 2 times 2? That's equal to 4. Now 3 to the power of 4 is just equal to 84. Now, our next question is x to the power of 5 over here, all raised to the power of 3. Now, what do we do? Remember, let's look at the base. The base is x, and then our exponents, our outside exponent is 3, and our inside exponent is 5. So we're going to multiply 3 by 5. Remember that multiplication, it doesn't matter which order you are multiplying by. It's commutative. Commutative meaning it doesn't matter which order you multiply, you'll still get the same answer. So if you say 5 times 3, you'll still get 15. If you say 3 times 5, you'll still get 15. So let's simplify this even more. X to the power of 3 times 5, which is equal to 15. So that is our answer for this second part. Okay. Now, for this one. In this one, we need to take into consideration that we have two bases now. And what do you notice about the two bases? We have x over here, and now we also have y. And those two bases are not the same. So therefore, we cannot write them as one. If you know what I'm talking about, we can't like write x and y like as a single variable. If you understand what I mean, like you're just gonna write, let's say over here, x, y. Well, I don't know what that is. No, we're not doing that. What we are going to do, right? We are going to just do it step by step, and just pay attention, please, and then you will understand this. So let's look at the basis, right? We have x and we have y. Let's look at the exponents, right? Or let's look at the sign over here. Can you see that we are multiplying the two bases? This means that they can actually be together like this. So we can write it x multiplied by, just take note that I'm leaving spaces because I'm going to write my exponents there. X multiplied by y outside of the bracket. Now what happens how does it look when we take it out of the bracket? Now remember, in the past two examples that we have done, we had the exponents from the outside multiplied by all the exponents in the inside. So we're going to do the exact same thing. We have the 2 on the outside, and we are just going to multiply it into all the exponents that are present. It doesn't matter what base it is, it doesn't matter whether they're the same base or the different base, they will always multiply by every single exponent that is inside of this bracket, inside of the bracket that is raised to, basically. So in this case, let's look at this. The power of 2 outside of the bracket, it's going to multiply into this 2 by the x. So we are going to write this as 2x to the power of 2 times 2. And then over here, with this one, let's do it in a different color. Can you see this power of 2 is going to multiply into this exponent over here, which is 4. So we're going to write it like this. But this is also affected by y. So it's going to be y to the power of 2 times 4. If you don't understand that, please backtrack and or just try and pay attention to what's happening. Try and see where I got these from, and then just use that all the time. It's gonna work all the time. Trust me. It's actually easier than anything. But backtrack, and then you will see where I got the numbers from. But let's continue. X to the power of, so we write x as itself over there, x to the power of 2 times 2, which is 4, and then multiplied by y to the power of 2 times 4 over here, which is equal to 8. So therefore, this is our answer for the third example. If you don't understand that, please backtrack with the video or rewind the video and see where I got everything from. Okay, let's move on to the next exponent law. Exponent law number 4. So, in the previous 3 exponent laws that we have done, we had addition with the exponents. The second one, we had the subtraction with the exponents. The third one, we had multiplication. So the fourth one can only be nothing other than division between exponents. So, let's see how we do this, right? Let's look at the base. That's the first step we always look at. We look at the base. We have x over here as the base. We can write this outside like this. Now, let's look at what is happening to this base and the exponents. We can see that this is being rooted. I'm not going to say square rooted because we can see clearly that there is an n over here. It's an nth root in this case. That's what we would say. But it's being rooted at the moment. Now, we can, in this instance, we can actually see that in order to divide by the exponents over here, we need to take into consideration that this x is being rooted.
I apologize if any of that didn't make any sense because there was a lot of external distractions on my side, but let me retry that again. We have x as a base, right, over here. We can write that on its own over here because of that. We can see this entire thing is being square rooted or just rooted, and we know that this last exponent law will be the division between the exponents. Whenever we see a root, we are going to just divide this. We are going to take the m over here. We're going to take the exponent that is within the root, and we are going to write it as the numerator. We are going to write it in fraction form, by the way, because that is probably the best way to express exponents. We're not going to say m divided by n or whatever. We're going to say m over n. But let's just do this. M is within the root, so we write that as the numerator. And when we have n over here outside of the root, over here, let me write that in a different color actually. We have n on the outside of the root. Apologies again. Let me look at that again. We have n, right? I circled n. The root, the root from the outside, or the number from the outside of the root, will always be expressed as the denominator. So it will be m over n. Let's just do some examples and then I can teach better from there. Yeah, this was a weird one because there were so many people going in and out of the room at the moment. So let me just do examples so it can be more understandable. Okay, let's do these examples. So the first example is the square root of 2 to the power of 4. Now remember, the exponent law is that we will always do this. And I'm just going to cut straight to the writing quickly. So as you can see, I have said that over here, the exponent will always be equal to the numerator. Every single exponent within the root will always be equal to the numerator, and the root, which is basically like the outside of the root, will always be the denominator. So let's do the examples and you understand what I mean. Okay, so we have the square root of 2 to the power of 4. So as you can see, we only have one base, so we can write that 2. 2 is our base over here. Now let's look at the exponent. Remember, we want to do numerator over denominator, exponent over root. Now clearly, what are we seeing over here? What is our exponent first? Let's analyze what our exponents are. This 4 over here is our exponent in this case. And where is our root? As you can see, it's a square root. If there's no number by this, it's a square root over here. If there's no number outside of the root, then you know by default it will just be 2. So let's do this. We have the exponent divided by, which is 4 over here, is divided by 2. That is our exponent right now. Remember, it's the exponent divided by the root. Now let's do this. We have 2 to the power of 4 over 2, which can also be written as 2 to the power of 4 over 2 is equal to 2. And what is 2 to the power of 2? That is just equal to 4. Okay, let's do the next example. We have our base. Our base is x, so we can just write that on its own here. Now, we have an exponent and we are also given a root. So we have z as our exponent and we have y as our root. And remember, whenever we are doing the exponent laws, when there's a root involved, we will say it is going to be the exponent, which is z all over y. Notice the slash is basically just a fraction. I just don't have so much space to write the full fraction. But anyway, we have x to the power z over y. And what can this just be written as? It stays the same. So I'm just going to write it better. We have x to the power of z over y. So that is our exponent. And this is our final answer. So let's move on to our final question. Our final question says the cube root of x times y to the power of 2. Let's analyze this. We have bases, right? Our base is x and our other base is y. So we know that we have to write them separately. So what we have to do is also consider the base x. What exponent does it have? Remember, if there's no exponent displayed, we'll just write 1 in as well. So now what do? Let's do it one by one. Remember, that is what we did in the brackets, or that is what we did when we were multiplying the exponents. We did them one by one because they had different bases. So let's look at x, right? With x, we take it out of the root. We can see that the exponent of x is 1. So we'll write that as 1. We can see that the root outside of this, outside is 3. So we can write that as 3. So 1 over 3. Now, it is still, remember, look at the sign over here. It's multiplying. So we have to write multiplied by, and the base y. Y, let's look at y. Y has an exponent of 2. over here. Actually, let me write it let me do it in a different color here. Y has an exponent of 2, right? And we can just write that down. The exponent is the numerator, and it also has a root as 3. So we can write the 3 as a denominator. So, what else can we say? Can we simplify this any further? Nope. This is the final answer. And if you pay attention to what I'm doing at the moment, you will actually understand where I got this from. If you don't understand, rewind so that you can actually see where I got the numerator and denominator from this exponent. Let's move on to the next one. Exponent law number 5. Okay, we're almost done. Exponent law number 5 is probably the one that students do not understand, that most students literally do not understand. And the reason why is because I'm going to tell you that this is actually it's actually a really easy one. It's probably like the most like, you don't even really have to use your brain. You just have to, okay, I'm going to put the N there, I'm going to put the M here, but I'll explain what I'm saying right now. With exponent law number 5, what do we notice that's a little bit different? Of course, yes, the N is here, it's not an exponent. But let's look at the exponent of x. We have negative m. Now, with these types of questions, or when we ever left with a negative exponent, some teachers will actually ask you to write it in positive exponent form. Now, how do we convert that? Let me show you. In order to change it to positive exponent form, we will do the following. We will do it as follows. Just pay attention at what I'm doing. With the n, right? Let's look at the n. The n value means the coefficient. So I'm going to write it here. It will be if. The n is the coefficient of x, basically. Coefficient of x. So we will write the coefficient of x at the top as the numerator. We're going to write it in fraction form, by the way. The n always goes in the numerator, and we have x over here as the base. So the base will go in the denominator side. Now, what do we do with this negative exponent? We have a negative exponent, which is negative m. Now, what are we going to do with the negative m? Remember when I said we are going to convert it to positive exponent form? So basically, this is just the inverse. This side over here is just the inverse of that side over there. And what we know about inverse is that there is going to be an opposite change. So let's look at this. We have negative m. If we write it in fraction form and it is in the denominator, we will write this m as positive m now. Notice how the m has changed from negative to positive. Let's do more examples and you'll understand why I'm doing this right now. Okay, so here's our 3 questions. Note that we are having in the same form. Our 2 over here is represented as n, which is the coefficient of x. Our x is represented as a base, and our negative 3 as an exponent is represented as our negative exponent. Now we are asked to convert this into a positive exponent form. How do we do that? Remember the form that I've shown you? We need to take the coefficient of x and we need to put it in the numerator. That is not a very neat tool. Let me do that again. We put the coefficient of x as the numerator. Now, what do we do with the x as the base? The base goes in the denominator. So that's also the second step. Now the third step is to look at this exponent. Because we have written it in a fraction form, we can now say that this is going to be positive 3. And this is the answer of the first question. Now, let's look at our second question. If you still don't understand, I'm sure you will now for the next one, or just backtrack if you need to. Let's look at this. We have x to the power of negative 1. So we are missing something. Remember how there would normally be an n over here, right? There would be n times n. In this case, if there is no coefficient of x, actually no, I have a question. What is the coefficient of x in this case? I'll give you some time. If you said 1, you are absolutely correct. Remember, If there's no number in front of x, you will just assume there's 1. Because 1 multiplied by anything stays the same. So, we know that this 1 is the coefficient of x. So therefore, we will write 1 as the numerator by default. Now, when we have x over here as the base, we will write this in the denominator. And remember, because we did it in fraction form now, we can just take this -1 and we can turn it into +1. Or we can just leave it as 1 over x in this case. Let's do the last question. The last question is a little bit different. We don't have x as the base, but we have 3. Now, funny enough, you'd probably think that we need to put the 3, because it's a number, over here. No, you do not put it as the numerator. What we need to take into consideration is if we only get a number as a base, we will, by default, put 1 as our numerator. Why is this true? Because we need to consider that 1 is being multiplied by 3. By default, obviously. We treat 3 as if it was x in this situation. So, because our base is 3, now we write it as the denominator. And we have the exponent of -2. We now need to write it as +2. Why is it +2? Because it is now in fraction form. And we can just simplify the answer more. We can write it as 1 over 9. That is how you do the positive exponent form. Let us move on to the last exponent law. You know, I didn't even need to add this one, but I did because it is a part of the curriculum. So let's go over the x to the power of 0. Let's just finish this off. It's actually not that difficult of a one to know. So what you need to know about when anything is raised to the power of 0, right? No, this is not a degree symbol. It's not degrees. It is 0. When anything is raised to the power of 0, we will just have a final answer of 1. Yeah, that's it, man. That's about it. No, I'm not going to end the video here, though. I will show you examples, and I will make sure that you will always, whenever you see anything raised to the power of 0, make it equal to 1. Let's move to the final set of examples. Alrighty, the final stretch. So, let us look at this, right? What we need to consider is the exponent and the base. But in this case, because the exponent is 0, we can just say that the answer is 1. X to the power of 0 is equal to 1. Let's look at the next one. We have 8 to the power of 0. Anything raised to the power of 0, the final answer will be equal to 1. Now, let's look at our other number. We have 123,489 all to the power of 0. What is the answer? 1. Yep, that's about it, man. So, when we are looking at the exponents, and let me go back to the page quickly, we can clearly see that these exponent laws are ways in which we can either learn how to add, subtract, multiply or divide exponents, as well as converting the negative exponents into positive exponents, and also looking at when we have something raised to the power of 0. Now, this was a video on the basics of exponent laws, and I will unfortunately not be doing too many questions or more examples because I don't want to keep this video too long. I don't want to make it a 2-hour video or an hour. I don't even know if it's an hour. I don't want to make this too long. But in this video, I've discussed all the exponent laws. Thank you very, very much for watching. I hope you understood, or I hope you understand exponent laws right now. If you don't, try to go over the video again, and I'm sure you will understand it. And if you have any other recommendations of videos that I should make for mathematics, please let me know. And thank you so much for watching.